Hi, hello everybody. Thank you for coming to this session. I'm going to use both mics, doesn't matter. My name is Ramzi Labban. I'm the CEO at Previse AI. Previse AI is a startup building machine language algorithms to help improve the predictability and profitability of construction operations. I'm going to try this. Okay, so let me give you a background about the construction industry. When I tell somebody I'm working with machine learning in the construction industry, I get a puzzled look. Why in construction? Construction is one of the largest industries in the world. It's around $11 trillion in 2019, expected to grow to $13.4 trillion by 2023. And the growth rate it's growing at, it's not fixed, it's growing. So it's growing at an increasing rate. It's been growing at 13.4% right now and expected to grow at 29.4% eventually. So this is huge. I wrote this and I want to read it because it's very interesting. The global engineering and construction sector holds the dual distinction of being one of the world's largest industries, yet one of its least efficient, and we're going to see why. In terms of digitization, it's one of the least digitized sectors in the world. In terms of productivity growth, it has a growth average of 1% per year compared to 2.8% global growth average compared to 4% in manufacturing. So productivity in the construction industry is pretty bad. And if we look at capital asset projects, capital projects are very large projects. 98% of capital projects are going to suffer either schedule overruns or cost overruns or both. Your average cost increase in a capital project is around 80%, and your average delay is around 20 months. This is very surprising. I mean, you don't expect it, but it's happening everywhere. So, in terms of applying artificial intelligence or machine learning really in the construction industry, very few attempts have been made to work with predicting performance or improving performance of construction. Most of the effort that has been done so far has been around safety by trying to capture what people are doing and are they doing it in a safe manner. Some work has been done in analytics and some work has been done in project schedule optimization. Nobody has done anything really in predictive performance. So this is what we're trying to do at Previse. In terms of startup investment in construction, this is very interesting. Over the past 10 years, investment in construction was really bad. In 2018, it went crazy. And the expectation for 2019, by the end of the year, is also to be much more than 2018. So we're looking at a major shift in how people think about technology in construction. People are investing more, people are trying to apply more technology in construction, and we're hoping that we will be able to change the construction industry with this. What we do at Previse is we have a product called Site Assist. It's basically the construction industry first AI-enabled equipment performance prediction model. What we do is we try to predict the performance of equipment, and we try to predict the maintenance. If you look at maintenance in construction, it's a major issue. If you're maintaining a generator in a facility, it's easy. Like it breaks down, yes, you're disrupting everything, but you can fix it in place. If a large piece of equipment breaks down in the field, it's a huge problem. Sending crews out to fix it, the disruption it creates, the domino effect it creates on the rest of the activities that come after this activity is huge. So what we're trying to do is we're trying to predict when equipment will fail so we can maintain it before it fails. In terms of equipment performance prediction, I'm going to turn around and read a bit because I don't have my laptop with me. Basically, we're trying to predict and evaluate equipment performance on construction sites, both during estimation and execution. When you're trying to price a project, you're trying to determine how many resources, for example, you need to perform a certain activity. And engineers try to estimate this by making assumptions. If you ask 5 engineers about a certain value, during the same day, you'll get 2 answers from every engineer. So 5 engineers, 1 question, 10 answers. What we're trying to do here is we're trying to remove that uncertainty in the answer that the engineer gives and replace it with an accurate prediction using machine learning and big data. Similarly, with predictive maintenance, what we're trying to do is we're trying to minimize the failure of equipment on construction projects. We want to make sure equipment does not fail, or minimum failure of equipment, so we don't have a lot of disruption because of failures. And failures happen, and they happen a lot, and they're costly to fix, and they're costly to recover from. Okay, so I'm gonna go a bit technical now, not too much. It's just a high-level technical overview of what we do. We collect a lot of data in construction. So we have in-vehicle monitoring system for equipment. We have telematics. We have edge sensors collecting data from different equipment or different sites. We have our asset management systems. We have our ERP, and so on. We collect all that data, but we don't do anything with it right now. What we are trying to do right now is we're trying to take that data and run it through our machine learning algorithms and try to improve the predictability of how equipment perform on construction sites. So I hate this microphone, but anyway. So when we're trying to predict the performance of equipment, I'm gonna take an example and tell you how we do it specifically for one specific example. And it's the truck speed prediction. And let me do this here. Imagine you're moving earth, like anyone in construction here understands what earth moving is. So if I have a big earth moving operation, I'm not talking about like 5,000 meters cubed of earth. I'm talking about 2 million, 5 million cubic meters of earth that we want to move. What happens is we excavate a piece of land, we load the material on trucks, and we cart away this material to a dump site. Trucks dump the material and they come back. When we're trying to estimate such an operation, one of the major components of this estimation is the cycle time of a truck. The cycle time determines how much time it takes a truck to load the material, cart away the material, dump the material, and come back. It's essential that we get a good estimate of the cycle time so we can get a good estimate of how many trucks and how many loaders, how many excavators we need to perform the job. And we need to get this right, because if we underestimate a project, we're gonna lose money. If we overestimate a project, we're not gonna get the project. And also, if we don't get it right to our planning execution, we're gonna lose money because we're gonna overrun our schedule, overrun our cost. So what we're trying to do here is, if we look at the typical cycle duration calculation, we have load time, hold time, dump time, and return time. Let's take hold time and return time. Hold time and return time are directly related to the speed at which the truck runs from point E to point B and from point B back to point A. So what we're trying to do right now is, instead of asking engineers to give us the average speed of a truck running from point A to point B or from point B back to point A, we're using machine learning to capture all the IoT data that comes in from the trucks while they're performing those truck trips, and trying to predict what the speed of the truck is going to be from point A to point B given a certain set of features. So what we did is we took a very large amount of data for the construction industry. 1 million records in construction is a large amount of data. And we cleaned that up, and we got around 400,000 useful truck trip data records that we could use for machine learning. And we applied this. 400,000 records seems like a small number for machine learning, but in construction, trust me, it's a very large number to be able to get your hands on. This covered 179 distinct trucks, 3 truck types, and 22 locations. I'm not going to go into all the features that we used. I blanked them out here for the public presentation. But what I'm going to say is we were able to reach a 94.1% accuracy using artificial neural networks to predict the performance of a truck based on 9 features. Those features included type of truck, size of truck, location of operation. Is it AM or PM? Are we operating during the day or during the night? What month are we operating in? Because this makes a difference in terms of weather conditions, temperature, precipitation, and so on. I'm not going to go into all the features, but we can see that the accuracy was pretty high for a construction project. We also developed an iOS mobile app that encapsulates the full inference model on the phone. So construction crews do not have to have access to the internet or be online to be able to perform any predictions on site. This is this has only 2 features. This is for a public demo only. The actual operating app has around 9 features. What it does is it enables the engineers on site to predict or to find the actual speed they're going to put into their calculation using the multiple features while disconnected. So the whole inference model is encapsulated on the app with no need for access to the internet. Okay. Basically, that's it. It's just a really interesting machine learning algorithm. And if you have any questions, let me know. Yes?
Thank you very much, Doctor. So we really have this problem in oil and gas, especially with the logistic moving rigs from different places. And I'm really interested to know this, the confidence factor that you said it's about 94%. This is based on a blind test that you compare your methodology with the conventional way of working?
So basically, the 94.1% accuracy, what we did is, to reach this final stage, we went through many iterations of testing different algorithms and trying to apply them to the data we had. And each time we applied those algorithms, we went back and compared to historical data that we had that was not run through the algorithms, and also run through validation data that had no relation to the actual data set we were working on. Our first runs were on, we used random forest, we used decision trees, we used a couple of other regression methodologies, and then we decided that why not try an artificial neural network for this, because the data was a bit complex, and we thought we might be able to get a better result by switching to a neural network instead of sticking with the traditional machine learning algorithms. Comparing them, random forest gave something very similar to artificial neural networks, but once we started getting a lot of complex data into the learning, random forest degraded and ANNs showed to be better. The comparisons were all made, the training was made on a large data set that was split into 3 splits. Like the initial split was for training. We had a verification split, then we had a validation split, and then we compared also to data that has never gone into any of the algorithms, just to make sure that we're doing a good job from that side. Thank you. Any more questions?
Dr. Ramzi, very interesting presentation. Well done. I have a question, like the algorithm that you've developed and the app, do you think, like, based on your experience, it can be applied throughout another supply chain throughout the construction phase? Thank you.
Yes, thank you for the question. That's a very interesting question, because we're looking right now at how to convert this know-how and this algorithm into an actual product that can be utilized not only in predicting specific operations, but also applied somewhere else. Yes, I believe with some changes to not only to the features, but also to the way we collect data for the different application are essential before we can apply it somewhere else. But definitely it's transferable, yes. I think there was a question back there. Yeah.
أول شيء يعطيك العافية.
الله يعافيك.
بحب أشكرك. بحب أسأل إنه في هذا المجال، كونه أنا مهندسة زراعية في الأمن الغذائي والزراعة المستدامة والتغير المناخي، هل ممكن أستفيد في ملوحة التربة بهذا البرنامج في إنه أعمل من خلال يعني الإحصائية إنه ممكن درجة الملوحة إذا زادت أو قلت أستفيد من هالأشياء اللي انطرحت؟
يعني المبدأ هو ذاته it's the same principle that can be applied to your problem, but with changes in how you're building your algorithm, in your feature analysis and determining what features you want to use, and also like you always start with the problem you're trying to solve. What is the problem or what is the question you're trying to answer? And you go back. This idea is directly applicable to what you're saying, but with major changes, not minor changes, though. It's a different data set, different features, but yes, applicable.
Thank you.
Sure. Any more questions? All right. Thank you so much.